Every single time you refresh your social media feed or check the weather on your phone, you're using something called an API. It's basically the messenger that fetches data from the internet for all our apps. And for a really long time, there was a standard way of doing this. But what if there was a smarter, way more efficient way for our apps to talk to servers?
Think about it this way. If you need milk, eggs, and bread, you wouldn't drive to the store for milk, come home, then go back for eggs, and then go out again for bread, right? No way. You'd make one list and get everything in a single trip. Well, that simple, common sense idea is at the very heart of the problem that GraphQL was created to solve, because the old way of getting data felt a lot like making way too many trips to the store.
So, for a long time, the dominant way to build APIs was a model called REST. The best way to think about it is like a restaurant with a fixed, set menu. You have these specific, separate destinations or endpoints for everything. One for books, another for authors. When you order from one of those, the server sends you the whole pre-packaged meal for that item, whether you wanted all of it or not. And this whole set menu thing leads to two really big, really common frustrations for developers. On one hand, you have what's called overfetching. This is where you just want to display an author's name, but the API sends you their entire life story, their date of birth, their list of publications, a ton of data you just don't need, which wastes bandwidth. And on the other hand, you have underfetching. This is when you get the book data, but oops, it doesn't include the author's name. So now you have to make a completely separate second trip to the server just to get that one little piece of information. It's just so inefficient. Now, this inefficiency wasn't just some small annoyance. Back in the early 2010s, it was causing a massive headache for one of the biggest tech companies in the world. As Facebook was making its huge pivot to mobile, they ran smack into a wall. So picture this. It's 2012. Facebook's brand new mobile apps are slow, they're clunky, and they're crashing all the time. The culprit? Their own APIs. Trying to pull together all the data for the newsfeed, posts, comments, likes, user profiles, required tons of separate requests, and making all those round trips over slow, spotty mobile connections was absolutely brutal. So their engineers decided to invent a whole new way to fetch data, built from the ground up to solve this very problem. And they called it GraphQL. And you can really hear their motivation in this quote from the engineering team. They were just plain frustrated. They weren't thinking about the server's rigid structure, they were thinking about what their app actually needed to show the user. And that developer-first mindset is totally key to understanding why GraphQL is so different. So with the problem laid bare, multiple trips, getting too much data or not enough, GraphQL shows up as this really elegant solution. It was a complete paradigm shift in how an app could communicate with a server. So what is it really? At its heart, GraphQL is a query language for your API. The most important thing it does is flip the power dynamic. Instead of the server deciding what data to send, the power shifts to the client, to the app. The app sends a single, precise request asking for everything it needs, all at once. And the server sends back exactly that. Nothing more, nothing less. And you can really see how different this is. With the old REST approach on the left, you might have this long, sprawling list of different endpoints for books and authors and publishers. With GraphQL on the right, there's usually just one. A single, powerful, intelligent endpoint. Every single request goes to the same address. Okay, so a single endpoint that can magically deliver anything you ask for sounds a little too good to be true, right? But how does it actually work? Well, it's not magic. It's actually a pretty straightforward three-step dance. Let's go back to our restaurant analogy. First, the kitchen, the server, defines the entire menu. This is called a schema. It's a super detailed blueprint of all the data you could possibly ask for and how all the pieces relate to each other. It's the single source of truth. Second, the customer, your app, places a very specific custom order. This is the query, and it describes exactly the fields it wants. And third, the server prepares and delivers that exact custom order as a neat JSON object that perfectly matches the structure of the request. It's no longer a set menu, it's ordering completely a la carte. And here's what one of those queries actually looks like. It's incredibly easy to read, even if you've never seen it before. The app is literally just saying, hey, get me the book with an ID of 1. And for that book, I only want the title. Oh, and for that book's author, just give me their name. See how it's nested? You can ask for related data all in the same go, no second trip needed. And then, here's the response. The data that comes back from the server has the exact same shape as the query we just sent. It's a perfect mirror. What you ask for is precisely what you get. For developers, this predictability is an absolute superpower. No guesswork, no surprises. Now, as much as it sounds like a miracle, GraphQL isn't a silver bullet for every single problem. It has some incredible strengths for sure, but it also introduces a new set of challenges and things you have to think about. So let's take a look at both sides of the coin. The big wins, the superpowers, directly solve those problems we talked about at the start. Data fetching becomes incredibly efficient. You kill overfetching and underfetching in one shot. This gives you a huge performance boost, especially for mobile apps. And one of the coolest parts is that you can add new features to your API without breaking old apps. You can just add new fields, and existing queries just keep working. It makes evolving your product so much easier. But, of course, there are trade-offs. It's a new way of thinking, so there's a bit of a learning curve compared to REST. Caching can be more complex since you're not just dealing with simple URLs anymore. You also have to be really thoughtful about security, doing things like limiting how complex a query can be so that nobody can abuse your API. And even error handling is different. Errors often get delivered right inside a successful response, so your app has to know how to look for them. But even with those challenges, the benefits have proven to be massive. This isn't some niche experimental tool. GraphQL has been battle-tested at an incredible scale, and today, it's the engine behind the massive, data-hungry applications of companies like Netflix, PayPal, and even Starbucks. So at the end of the day, GraphQL isn't just a simple replacement for an older technology. It's a whole new philosophy. It forces a shift in focus to the needs of the application first, empowering developers to build better, faster products. It's about moving from thinking in terms of a rigid list of endpoints to seeing all your data as a single connected graph. Which really leaves us with one final thought. Are your APIs asking for what they truly need?